Hello and welcome to a new tutorial. If you have already used a true first-person camera, you probably noticed that there is head bobbing caused by the animations of the character mesh. In this tutorial I want to show you a way how to reduce this head bobbing effect. So before we start, I just want to demonstrate to you what we're gonna do. For a better understanding how the first-person camera will behave, I made a view from the side. So right now the first-person camera is attached to the capsule component. That would mean that we have no head bobbing, but there's a problem. If we're jumping, then you can see that the character mesh is moving really far away from the camera, and that has the problem that we could see our own head if we're looking upwards while jumping, and because of that want to stick the camera somehow to the character's head. And if we're going to do that like this, so now the camera is attached to the head bone, but that also means that we have this influence by the character animation on the camera location. And if we're running now, you can see we have this strong head bobbing, and that's also not what we want. So now we can take the good points out of both variations and mix them, and that would look like this. As you can see now, if the character is standing, we have no camera movement at all, and if the character is running now, you can see that there's still a bit of camera shake, but it's reduced a lot, and that's because we are smoothing the camera location, but jumping or running has no influence, so it's just smoothing out this little movement from the head. So let's start. That's actually the default third-person template. The only thing I've changed are the materials, so you will see the effect better in the end. So first we are going to our third-person character and open up. And we're going to viewport and setting it up for first person. So for that, go to class defaults and search for jaw. And here, use controller rotation jaw. We want to set it on true. That means that our character will always face to the direction we are looking at. And always if you set that on true, we want to go to the character movement component and search here for orient and set it on false because we don't want to have the character oriented to the movement rotation. Now we can delete the follow camera and the camera boom because that's third person stuff. And now, important, click on the capsule component and add a new camera. And let's just rename it to FP camera. And yeah, just make sure that the camera is attached to capsule component and not the mesh. Yes, so click on the first person camera here. We can actually move it a bit here, fitting, but that doesn't matter because the camera location will be overwritten anyways later. So click on the first person camera here and set the use pawn control rotation on true, so we will be able to look around. The next thing we want to do is moving the character bit to the back. So by, for example, 13 units. That just makes sure that we don't get into clipping problems where we are looking through wall or through the head. So we need a bit of distance here to the back. Yeah, so now go to the event graph and adding a new event tick. And this event tick should fire a function we will create now. let's call it update camera location, and go back to the event graph and make sure that the event tick calls this function like this. And let's imagine we are multiplayer or having this character placed in a level more than once. This event tick will run on fire on each player for each character, but the camera, the first person camera, is only relevant for the owning player. So we just make sure that we don't calculate it for each character, but only for the owning character. So let's add here an if, and for the condition, tag is locally controlled. That's just important to save some performance if we have this character placed more than once. So now we're starting by smoothing the camera's Z location. So for that, we're creating a new variable. Make sure that's a normal variable and not a local variable, because then it wouldn't work anymore. So add a new variable and call it like current relative cam log Z, and that should be a float. So we're setting it here and we're smoothing it with a finterp 2. For the target, for the current, we're actually taking the variable we just created. And for the target, we're taking the relative location of our head's bone. So here with skeleton, if you have a different skeleton, open it up and look what's the name of your head. In this default skeleton mesh, it's just called head. So we go back to the event graph, not to the event graph, to the function we just created, drag in the mesh and get the socket location. And because it should be the relative value, relative Z value, and with that we're getting the world absolute value. First, for the socket name, type in here head. So that's giving us the world space location. So if we are jumping, and so that would have an impact, but we don't want to have an impact if we are jumping. So we want to have calculate this to the relative location. To do that, let's break it and get the actor location, and we want to subtract this by the Z value of the actor location. So now that's relative and should be our target. Actually, what we can do here, so that's not, the camera is not placed at the chin of the character, more like a bit higher, more at the eyes or so. Let's add here a bit offset to the top, maybe 5 units or so. And for the delta time, we're just taking the node get world delta seconds. And for the interp speed, we're also taking a variable. So we promote it to a variable. And let's call it just camera smoothing speed Z. And click again on it. On default, we can set it on 3. So let's just comment that. And the next thing we're doing is to convert it from relative again back to world space. And to do that, we're getting again this get actor location break vector thing. And we're creating a new variable. Let's just maybe duplicate this one. And let's just replace the relative with world, current world camera location Z. And we're setting it here. Let's connect it here. And for that, we're taking the relative camera location again. And we're just adding again the Z value. So here we subtracted it to make it relative. And here we add it again. Like this. Just comment it again. Great. So next step, we're actually setting the camera's location. So drag on the camera node again and say set world location. So connect it here again. And let's make a vector here. For the height, we are taking the current world camera location Z. And for the X and Y value, we're taking again the head bone location. Give a bit more place here. So we can take again these two nodes. And we don't actually want directly take the head location for the X and Y values, because it will be like in the center. We want to move it a bit forward, so the camera won't be in the inside of the head. So moving it a bit to the front. To do that, we're getting the actor rotation and the forward vector. Actually, the forward vector has a length of 1, so we can multiply it by float of, for example, 20. And now we are moving this direction vector 20 units to the front. And we're just adding this to the head's location. So it will take the head location, but 20 units moved to the front. So let's just adding this here. And now we can break it and take in the X and Y values here. So let's name it again, comment again. Next step would be, so now we just smooth the Z location. But we also have a bit of head bobbing along the Y axis, and for that we can just set it to a fixed value. So set it always to 0, for example. So next step, we're setting the relative location of the camera. So for that, drag in the camera node again and say here set relative location. And here we want to make this vector again. We can just leave the y value on 0. For the x and z value, we are doing a bit different. Depending on if we are moving or not. So let's say the character is standing, then we can just zero the head bobbing completely, so the camera will be set to a fixed location and not moving at all. And if we run, we're just taking the current x and z values we also have calculated here. So how we do that? Let's connect it for now here. We are actually, for the x and y values, we are taking a lerp. And for the alpha, we're creating a new variable. Again, a normal variable, not a local, just a normal promoter variable. And let's call it alpha movement. So we'll set it in a bit to 0 if we're not moving and 1 if the character is moving. So if the character is not moving, then it's A, so 0. Then we could take, for example, 28 for x value. And for if the character is moving, so if it's alpha 1, it will be B. And then we're just taking the current relative location, so we get the relative location, break it, and take the x value for that. So we can actually duplicate this lerp for the z. Make sure for A, so if the character is standing, we could take, for example, 63 as fixed value here. And for B, we can take directly this one, or we can make here an add, and we can add here available to have a bit of offset. Let's promote it again to a new variable and call it camera offset z. So I will just leave it for this tutorial on 0. But for example, you can use it if you're creating a custom camera walking animation where the camera should move up and down. You could animate it somehow, and then this will be the relative offset that will be added to the camera height. So it could be useful. So now we should set the alpha movement. That should be set to 1 if we move, and if we stop moving, then it should be set to 0 again. And we made it here with lerp, so we can fade it a bit between these two values, so it will look smoother. For that, we are setting the alpha movement, taking again a finterp 2. For the current, we're also taking the alpha movement. Let's connect it like this. For the interp speed, we could take something like 10, and the delta seconds, got the delta seconds, wrote delta seconds again for the delta time. And now for the target, as I said, if we are moving, it should be 1, and if we're not moving, it should be 0. So how to find out if the character is moving? For that, we are getting the character movement component and getting the velocity. this. And now we can get the length of the velocity. And if that is bigger than 0, then the character is moving. The character is also moving if it's currently jumping. To check that, we can take the is falling and take here an or. So if the character is in air or the character is moving, then we can connect this. And now, if this boolean is true, so a true boolean is 1 and a false boolean is 0, so we can directly drag this into the target. So if the character is running or jumping or so, then it will be true, and with that we will convert it to float, so 1, and if the character is not moving at all, it will be 0. So actually exactly what we want. So we can comment this again. And for that, we can take, let's say, reduce head moving by setting a relative location. So great. We're actually we're done with this function, but we have a few things we can also do in the event graph again. So if the character is in air or jumping, then we want to have the camera stick to the head, because the jumping animation is moving the head too fast for the smoothing interpolation. So now we want to find the two triggers when the characters start jumping or falling off a ledge. First, we can take this input action jump. And second, we can search for event on walking off ledge. And then we can check with the branch again if the character is locally controlled, so connected here with the pressed and with this event here. And so at the moment the characters start jumping or falling, then it's playing the start jumping animation, and we want to immediately set the smoothing speed on the z-axis on 0. So take this and just set it here on 0. And now the moment the character is landing again, we want to set it back on the default smoothing speed. So just search for event on landed. Take a check here again if the character is locally controlled. And now here we set the default value on 3, so we set it back on 3. But at the moment the character is landing, there's still this small landing animation playing. So we just want to set it after 0.2 seconds, again on the default value of 3. So now we can check it out. There you see, it works fine. Yeah, I tried to find good values for this character, but there might be better values, or if you have another character, there might be more fitting values for your character, but you can just tweak around with the values. And I really hope I helped you with this tutorial, and see you next time.